Hello, I'm Charles, a grade 9 IB student, and I'm very interested in game theory. I would like to show you a few scenarios from game theory. To start off, most people start off game theory by using Prisoner's Dilemma as an example, so I will as well. I am sure most people have already heard of lots of different versions of this problem. The problem goes like this. Two members from a criminal gang are arrested and are currently being interrogated. The police isolate both criminals and offer them the same deal. If one of them defects and the other stays silent, then the one who defects will be set free and the silent one will be locked up for 3 years. If both of them stay silent, then they will both only stay in prison for 1 year each. But if both of them defect, they will both spend 2 years in prison, as seen in this chart here that I made. We need to set a few restrictions. 1. Each person is infinitely reasonable and logical. They do things with reason and think of the smartest possibilities. Each person is infinitely selfish, only trying to get the best for themselves. Okay. If you have never heard of this scenario before, you would choose to stay silent. The problem with that is that the other person will try to optimize their own profits instead of thinking for both people. He only thinks for himself. He thinks, if I defect while the other stays silent, I will go free. If both people think like that, both will serve 2 years. Let me explain it using the chart. So Ash is this first column and Bob is this first row. Say Ash is, if we look in Ash's point of view, if Bob stays silent, then Ash can either defect or stay silent. Ash would choose to defect since he is selfish and would choose only his best outcome. So since 0 is less than 1, he would pick to defect. If Bob defects, then Ash still has the same two choices, defect or stay silent. We can tell defect is the better choice because 2 years is better than 3 years spent in prison. Similarly, if we look in Bob's point of view, if Ash stays silent, then Bob will choose to defect since Bob will be set free. And if Ash defects, then Bob will still choose to defect since 2 years spent in prison would be better than 3. We can tell both people choose to defect. This part is called the Nash equilibrium. The Nash equilibrium is an equilibrium named after the famous mathematician John Forbes Nash Jr. It shows what the desired option for each person in the game is. Mathematician, sorry. You might be thinking, can't the two people just team up together and both stay silent? Well, game theory just assumes each person is trying to benefit themselves the most and does not care about other people, so they would choose to defect. That way, they wouldn't need to spend any time in jail. If both people think like that, they would both choose to defect. The only way around this is to make this scenario happen more than once, so that they have to rely on each other. If they want to have the best outcome next game. There are lots of examples of the prisoner's dilemma in real life, such as in sports. Doping is an action sometimes done by athletes to give themselves better performance. Sometimes better performance. Two athletes have the choice to dope in a competition. If neither athlete takes the drug, then neither gains an advantage. If only one athlete does, then that athlete gains a significant advantage over the other. But faces the possibilities of being caught. If both athletes take the drug, however, the benefits cancel out, but they both have the risk of getting caught. Another example of the prisoner's dilemma is in the Cold War. It started after the Second World War ended. Both sides, America and the Soviet Union, could choose to either stop making weapons or continue. If one continues, then they will be the strongest in the world, since both countries want to have the largest military on the planet, they both started making even more weapons, since they both wanted to be the most powerful country on the planet. Both countries could have avoided spending millions of dollars that were ultimately useless by just signing an agreement. But both do not trust the other, so they would both secretly expand their military, thus creating a prisoner's dilemma. Okay, so this table is quite important, so let me talk about it again. So if Ash defects, Bob can choose to either defect or stay silent. Bob thinks, if defecting makes me stay in prison for 2 years and staying silent makes me stay in prison for 3 years, Bob would want to get himself to stay in prison less, so he would choose to defect. If Ash stays silent, then Bob still has the same choice. He can either defect or stay silent. Bob looks at the results. If Bob defects, Bob will be set free, but if Bob stays silent, he will have to spend 1 year in prison. So he thinks being set free is better. Ash will think similarly. If Bob defects, Ash can either defect or stay silent. Defecting would make him stay in prison for 2 years, and staying silent would make him stay in prison for 3 years. He would think defecting is the better choice. And if Bob stays silent, Ash will still choose whether he wants to defect or stay silent. If Ash defects, he will be set free, but if he stays silent, he will have to spend 1 year in prison. So he would think defecting is the better option. If both people defect, this is called the Nash equilibrium, but it isn't the best for the group. The best for the group is both staying silent, but each person is selfish, so they can't do that. Thank you for watching. I hope you understood, and if you have any questions, feel free to comment down in the comment section below. Thank you for watching, and see you next time.